Death Valley National Park holds the record for the hottest air temperature, reaching an extreme 128 degrees Fahrenheit. It is a parched, hostile basin of salt flats and desert scrub, where extreme heat defines the landscape. But tucked into a remote corner of the park is a dry lake bed known as the Racetrack Playa. Here, isolated boulders sit at the end of long, synchronized trails carved directly into the cracked, flat earth. These paths stretch for hundreds of meters, ending at solid chunks of dolomite and syenite weighing up to 700 pounds. For over 70 years, visitors and researchers documented the aftermath of these movements, yet no human had ever actually seen a rock slide across the playa. Without direct observation, theories filled the void. Explanations ranged from hurricane-force winds and violent dust devils to intense magnetic fields pulling them. In 2011, paleobiologist Richard Norris and a team of researchers launched the Slithering Stones Research Initiative to gather hard data. Because the National Park Service prohibits interfering with the natural stones, the team brought in their own similar rocks. They hollowed them out to install custom, motion-activated GPS units and placed them on the playa alongside high-resolution weather stations. The researchers braced themselves for a 5 to 10-year wait. One of the team members even suspected they had designed the most boring experiment ever conducted. Capturing an invisible, intermittent force meant abandoning short-term observation. They set their automated traps and left the valley. Just 2 years later, in December 2013, the team returned to check their equipment. They arrived to find the normally bone-dry playa covered by a shallow pond. This diagram shows a cross-section of the playa bed, highlighting the first necessary condition for rock movement. The water layer is roughly 3 inches deep, precisely enough volume to allow ice to float, while leaving the upper mass of the rocks exposed to the air. As nighttime temperatures drop below freezing, the surface of the pond solidifies. Crucially, the water underneath remains liquid, creating a frictionless boundary between the ice and the mud below. The resulting freeze creates what is known as window pane ice. At only 3 to 5 millimeters thick, it maintains structural integrity across a wide area without freezing solid to the ground. Out on the playa, this creates a vast interconnected puzzle of brittle ice sheets resting on top of the shallow water. When the midday sun hits the basin, the environment warms. The window pane ice begins to pop and splinter, breaking apart into massive floating panels. This top-down diagram illustrates the next variable. A light, steady breeze of about 10 miles per hour sweeps across the basin. The wind catches the immense surface area of the floating ice panels, pushing them across the pond. A single sheet of 3-millimeter ice cannot lift or push a multi-hundred-pound rock, but as dozens of these panels collide and pile up against the exposed backside of the stone, their momentum accumulates. This transfer of kinetic energy is known as ice shove. The kinetic force of the ice shove drags the heavy rock through saturated mud. It moves at a creeping pace, barely perceptible from a distance. Because the rocks are locked within the same migrating ice flow, they move in unison, etching long, parallel, and occasionally intersecting trails into the earth. Moving these massive stones required no supernatural forces or violent weather. It relied entirely on a delicate, highly specific alignment of shallow water, window pane ice, and a gentle desert breeze. These variables align with incredible rarity. Researchers calculate that the rocks spend roughly 1/1,000,000th of their time in actual motion. Tracking historical movements reveals a stark reality. Since the 1970s, the frequency of stones sailing across the playa has steadily declined. Overlaid with local climate data, the cause is apparent. Rising winter temperatures in Death Valley prevent ponds from forming the critical window pane ice. Without precise freezing conditions, the mechanical sequence breaks down. The pond water evaporates or sinks into the mud before the wind can mobilize any ice. For decades, the sailing stones captivated the public as an unsolved geological puzzle. Now, as the local climate warms, that puzzle is transitioning into a physical impossibility. The 2011 experiment solved a 70-year-old mystery. It also captured a documented record of a highly fragile physical process, right before the environment became too hot to sustain it.